Creating airplanes from recycled materials is an interesting concept that aligns with sustainability goals and environmental consciousness. Using recycled materials in airplane construction can have several potential benefits and challenges. Benefits: reduced environmental impact. Using recycled materials reduces the need for virgin resources, which can help conserve natural resources and reduce the environmental impact associated with mining and processing raw materials. 2. Energy efficiency. Some recycled materials may require less energy to process compared to manufacturing new materials. This can lead to lower energy consumption during the production of airplane components. 3. Lower costs. Depending on the availability and cost of recycled materials, using them in airplane construction could potentially lower production costs, making air travel more affordable. 4. Sustainability. Incorporating recycled materials demonstrates a commitment to sustainability and eco-friendliness, which can be appealing to environmentally conscious consumers and regulatory bodies. Challenges. 1. Material quality. The quality and consistency of recycled materials can vary significantly. Ensuring the strength, durability, and safety of recycled materials used in airplane construction is crucial. 2. Certification and regulation. Aircraft certification and regulation authorities, example, FAA in the United States, EASA in Europe, have stringent requirements for the materials used in aircraft construction. Meeting these standards with recycled materials may require extensive testing and validation. 3. Weight and performance. Airplane materials must meet specific weight and performance criteria. Using recycled materials that are heavier or less structurally sound than traditional materials could affect the plane's performance and fuel efficiency. 4. Supply chain challenges. Securing a consistent supply of high-quality recycled materials can be challenging. Airplane manufacturers would need to establish reliable supply chains for these materials. 5. Recycling processes. The recycling processes themselves must be environmentally friendly and energy efficient to ensure that the overall environmental impact is reduced. 6. Safety and liability. Ensuring safety and addressing potential liability issues associated with using recycled materials in aircraft construction is paramount. In practice, many aircraft components are already made from recyclable materials, such as aluminum. Increasing the use of recycled materials in airplane manufacturing is a worthy goal for the aviation industry, but it requires careful consideration of the technical, safety, regulatory, and supply chain challenges involved. Additionally, it may be more feasible to incorporate recycled materials into certain non-structural components of the aircraft, such as interior furnishings or insulation, rather than critical structural elements like the fuselage or wings. Certainly, let's delve deeper into some of the aspects related to using recycled materials in airplane manufacturing. 1. Material selection. To create an airplane using recycled materials, manufacturers would need to identify suitable materials that meet the required strength, durability, and safety standards. While aluminum is already commonly used in aircraft manufacturing and is recyclable, other materials like composites, titanium, and high-strength steel are also essential components in modern aircraft. Finding recycled alternatives or incorporating recycled content into these materials can be challenging. 2. Certification and testing. Aircraft must undergo rigorous testing and certification processes to ensure their safety and airworthiness. Any changes in materials or construction methods, including the use of recycled materials, would require extensive testing and validation to meet the stringent regulatory standards set by aviation authorities. This process can be time-consuming and costly. 3. Heavier materials, even if recycled, can impact the aircraft's overall weight, which can affect fuel efficiency and performance. Striking a balance between sustainability and performance is a complex engineering challenge. 4. Life cycle assessment. Evaluating the environmental impact of using recycled materials in aircraft construction should consider the entire life cycle of the materials, from extraction and processing to disposal. Recycling may reduce the environmental impact in some stages, but it might increase it in others if not managed properly. 5. Supply chain management. Ensuring a stable and sustainable supply chain for recycled materials is vital. Dependence on a consistent supply of high-quality recycled materials is essential for manufacturers to meet production demands. 6. Aerospace innovation. Advancements in materials science and technology are ongoing. Researchers are exploring new ways to make aircraft manufacturing more sustainable, including the development of novel materials that are both lightweight and eco-friendly. This could potentially reduce the reliance on recycled materials and open up new avenues for sustainable aircraft design.